All right, so let's talk about subroutines. So here, there's a program named caller and a program named hello sub. So here, it's going to, this one's going to call the other one. It's going to call hello sub. And by the way, notice the working storage section with variables starting with WS. Since COBOL uses complete words, many words you might want to use for a variable name are already used. So a traditional best practice is to always use any variable you're going to use, start with WS dash. That way you know it's not already been reserved by the system. So this is going to call something called hello sub, and that's in a different file. So you put that in a file called hello sub.cobol down here, and it has its identifier up here, hello sub. And now it has a linkage section, which links to a variable from up here. That's how parameters are passed in. So here I called it using WS name, and it goes down here. Here in the linkage section, I give it another name for the linked storage name, and now I can refer to it. So up here, I fed in WS name with the value dolly, and this other program will print hello followed by whatever name you feed in. So when I see hello dolly, that means it's combining data from this program with data from this program. And the only trick is when you compile it, you have to tell it that. You have to tell it, I want to make one program named caller, and I'm going to use 2 source files for it. So that's the one that does it. And so if I cat the caller.cobol, you see, this is the one with the that calls the other one and passes a parameter in. And if I cat hello sub.cobol, this is the one with the linkage section that is a subroutine dependent on the other program. And so when I compile them together here, I've created caller, and caller now has hello dolly, where part of it came from the calling program and part of it came from the called subroutine. So this is how you can organize your code to handle bigger problems by breaking routines up into different files. And so, for example, you can do factoring to try to factor a number. This will check numbers to see if is j a factor of I and go through a loop looking for them. And it's going to call divider subroutine, passing in I, j, and factors. And so you have to, and here's what goes into a divider subroutine to do it. So you can make a program that will tell you if j is enter I and you enter j, and it'll check them. And then you can solve more problems like finding prime numbers with simple tests, the one thing you can do there. And there's more you can do. If you go here, which now that you can organize and reuse functions, you can define a function that will calculate to convert a letter to ASCII. And save it. So you've got that routine. And then you can do modular arithmetic, arithmetic on a ring. So if you had a ring of 9 modulus 9, if you add 1 to 8, you get 0. If you subtract 2 from 1, you get 8. You always stay on this modulus. So you can use there's a divide verb that can output the remainder, which is kind of a good thing. If you look at this tutorial of COBOL, you can use different verbs. And in particular, there's a divide verb. And I'll just use find to find it. And all right, let's do divide. Be more specific. No matches. There it is. All right. So there's the verb. So you divide into that. And the result is stored in B. And you'll find that there is a way to get the remainder out of it. Yep, here's the remainder. Divide number A by number B, giving the quotient remainder rem. So you can get the remainder out of there, and that's the way to do modular arithmetic. All right. And so then you can do multiplication on a ring. Once you can do modular arithmetic, you can just do the calculation and then do the modulus of it. And then you can reverse multiplication, finding modular inverses. There are smarter routines like Euclid's algorithm, but one way to do it is to just do a brute force through all possible values until you find it, finding a multiplicative inverse. So these are simple mathematical operations that are possible in COBOL, and they give you a little practice writing these programs. And if you're really crazy, you can go as far as I went, RSA encryption, where you do RSA encryption, the whole thing in COBOL, which is a little crazy. I actually wrote a CTF where I did RSA encryption in assembler, and that's what I said, this is getting a little too insane. But anyway, you can make an RSA program. You'll have to add the modular inverse routine here, and this will, if you enter P and enter Q and enter E, it will calculate N, phi, and D, which are the other parameters for RSA. And so that's the process of creating public and private keys. And then you can encrypt and decrypt messages, which is really just a matter of doing modular multiplication and modular arithmetic. So the previous routines you made will work it. And you can try various routines for modular inverses. You can use various routines to find primes and so on. So you can go all the way to do crazy stuff in COBOL for more practice if you want to. Anyway, that's the basic COBOL programming. And I'm going to do these two in the next video.